All right, Dr. R here, covering epidemiology. So let's take a look at this question. First off, what I'd like you to do is pause, read the question lead in, take a look at the answer choices, and then if you need to, go back to the question stem. So pause and try to answer the question and write down why you think these are correct and incorrect. All right, so let's look at the question lead in. Which of the following is an advantage of using non-probabilistic sampling in this case? So let's just take a look at advantage of non-probabilistic. So non-probabilistic. So non-probabilistic are things like where I, as a researcher, look at creating the sample sizes or creating the different groups within a study. So I might use my own judgment of what I think is important. We also might look at the convenience, how easy it is for me to get participants into the study. And we might also look at how available are participants to get into the study. So these are some of the things for non-probabilistic in order to be able to get them into the study. There are issues with this. So for instance, if we had two groups and I decided to choose based on their availability, so I had only 2 days and I sent out 1,000 emails or tried to recruit 1,000 people in the population, but only 300 of them showed up, and I enrolled only the 300 either into the experimental group or the control group. That leaves 700 people that potentially could have been in here. So that leaves the generalizability of these two groups to that 1,000 problematic. This is what's called a sampling error or a potential sample error or bias because we have unbalanced groups potentially. Doesn't mean we have unbalanced groups. We might get really lucky and the 300 are a great representation of the 1,000, and the 150 that I put in here and the 150 that I put in here are a great representation of those in the population that should be in the experimental and those in the control. So this might work out, but it is less likely that that is going to work out, and it could be problematic. You could also do like a convenience sampling as well, or use my my judgment to design the sampling and the characteristics. So that is non-probabilistic. So let's take a look at some of these answer choices before going up to the question stem. Non-probabilistic sampling allows the researcher to obtain a representative sample of the population. Well, we just talked about some of the biases or the bias that might come up with this unbalanced issue of how we're designing these two groups. So it's less likely to be a representative sample of the population. So I'm not a big fan of that one. I think it's actually the opposite. So non-probabilistic sampling is less biased than probabilistic sampling. So let's talk a little bit about probabilistic. So probabilistic, let's talk about simple randomization. Simple randomization would take a population and then we would make two samples out of it. There's a bunch of people. And so we have an equal chance of becoming, and this might be your experimental group, this can be your control group, an equal chance of each one of these becoming or getting into the experimental group or the control group. So the likelihood of us having a balanced group of experimental and control increases because we are randomly selecting, one goes here, one goes there, and we have a good chance or an increased chance or increased probability of getting a balanced sampling, a balanced group, which if that is true, then it would make both of these quite generalizable or representative of the population. There's also stratified. So stratified sampling, I talked in depth in one of my previous questions, but we can look at stratifying by age, by weight, by height, by gender. There's a bunch of different things. So you could imagine that within these two samples, we might need to stratify by BMI, underweight, overweight, that kind of stuff. And so then what ends up happening is we have a less than equal chance, so less than 50-50 chance of each member getting into one of these stratifications, right? And so you can imagine weight, height, and so each one of these are a stratification. That's what stratified means. And then clustering. So then clustering is often seen when we do things like location. So we might cluster patients by zip code, right? So you can imagine in a population, if we have all these people in a population, we might cluster them by a zip code. And those zip codes might not actually be the same size or have the same number of people in them. So they're really clustering. So you can imagine that this has a less than equal chance of a person being in a specific cluster if we do by zip code. All right, so non-probabilistic sampling is less biased than probabilistic. I would argue it's the opposite, because if we are using chance to create these groups, even if it is a little unbiased, less than equal, it is more likely to have balanced groups than doing something that is just not using chance at all and is me choosing as a researcher who goes in where. So I don't agree with that one. Non-probabilistic sampling is quicker and less expensive than probabilistic. And this isn't the greatest answer, but it's not completely incorrect. So non-probabilistic sampling, doing this like convenience sampling and doing something by patient's availability, can be quicker because you have to put a lot of time and effort into doing this randomization. You have to actually get the population, then give them a random number, and then actually put them in a group in order to be able to do the study. It can be quite expensive, it can be quicker, but it's not always that way. But maybe in this situation, that might be true. So I'm not going to rule that one out, but I'm not a big fan of it. So non-probabilistic sampling provides accurate estimates. Well, non-probabilistic and accuracy don't go together. Remember, when we're talking about accuracy, we're talking about things being unbiased, and we're talking about them having generalizability in this situation. So that is not what happens in non-probabilistic, right? You're going to have a greater chance or greater likelihood of being more accurate in your outcomes if you do a sampling or a randomization by chance. So I'm not liking that one, so I'm going to cross that one out because I believe it's the opposite. Non-probabilistic sampling reduces the risk of sampling error. Well, that is not true. Remember, we talked about sampling error here. So this includes sampling bias and sample error in non-probabilistic. So we've ruled out all four of these, and it looks like since this one is not completely incorrect, it would be the most likely correct amongst all of these. Now let's go back and see if that makes sense. So a researcher is interested in studying the prevalence. Remember, prevalence is the total number with the disease over those in the total number in the population, right? So that's the prevalence. And that's at a specific time period. So if you want to look at that, right? So that is here at a specific time period. We have the disease, all cases, and the total population. All right. So the prevalence of a rare disease. All right. So yeah, having a rare disease in a population. So you can imagine we have a population of 1 million. I mean, I don't know what the population is here, but let's say we have 1 million. And we only have 2 people in the entire cohort that have this rare disease in a small rural, it's a small rural community, so it's not going to be 1 million. So let's say there are 10,000 people in this small rural community, and there's only 2 people here. 2 people that have the disease. If we do a randomization, we might not ever capture these 2 people. We're going to have to make sure we enroll the entire population. So if we do a randomization, there's only 2 people that have this population. To get them into the experimental and the control group is going to be very difficult. We're basically going to have to enroll all 10,000 people, randomize them, and have 5,000 here and 5,000 there to increase the likelihood of getting that. That is super expensive. That is super problematic. And so really what we're going to be looking at is using non-probabilistic is probably going to be more likely to be fruitful if we're looking on rare diseases. She has, so rare disease in a small rural community. She has 2 sampling options, probabilistic or non-probabilistic. She decides to use non-probabilistic because of the advantages it offers over probabilistic. All right, so we talked about advantages and disadvantages. So now I'm okay with choosing C. Non-probabilistic sampling is quicker and less expensive. In this situation, given that there's a rare disease, small rural community, I agree with this now even more. C is the correct answer. I hope you also agree.